All right, in our last video, we learned what the GCF was and how to calculate it. And this time, we're going to start to learn to use the GCF to factor expressions. In order to factor using the GCF, you should already know how to find the prime factorization in GCF. We did that. But you should also know how to find the quotients of monomials. So if you don't know how to simplify the expression 60uv cubed w over 48u squared v squared, then you need to go back and review your properties of monomials. Why don't we try this one together? Factor 24x squared y minus 40xy. First, we need to find the greatest common factor between the terms, which is 8xy. Next, we place it outside a set of parentheses, and we divide each term by the greatest common factor. Now, this is an important step. By multiplying everything by 8xy and dividing everything by 8xy in the parentheses, we're essentially multiplying the entire expression by 1. So it just changes how the expression looks, not what the expression is, and that is factoring in a nutshell. Let's go back. So now we're going to simplify inside of our parentheses to get 3x minus 5, and our final factored form is 8xy times 3x minus 5. Let's try this next one on your own and restart the video when you're ready to check your work. Okay, the GCF is 14r cubed s. And we're going to take that outside of our parentheses and again, divide each term in our original expression by the greatest common factor. I simplify in my parentheses to get 4rs squared plus 2s plus 3. So that's my final factored version. Not so bad, right? Let's say I need to factor this expression. It looks a little different, right? Same idea. We always start by identifying our greatest common factor, and that's the key to this particular problem. In this case, it's a binomial. Okay, remember, our GCF does not have to be a monomial. Can you see what it is? Excellent. The greatest common factor is v minus 1. So I bring it outside of my parentheses, and then again, I'm going to divide my expression by my greatest common factor. I simplify in my parentheses, and I'm left with u minus 2 inside. So my final factored form is v minus 1 times u minus 2. Let's box that, and we're done. This is our final example, and of course I had to make it a little bit tricky. Do you see a GCF between our two terms? Surprise! We have opposites. S minus 4 and 4 minus s are opposites of each other. So in order to get them to be the same, we're going to switch the order of the terms and bring a negative sign out front. As a result, we'll have a positive sign between our two terms, but we have our greatest common factor of s minus 4. So I can factor my s minus 4 out, and what's left in my parentheses is 7 plus 3s. And my final factored form is 7 plus 3s times s minus 4. Okay, so we have learned the first step in factoring any polynomial. We always start with our GCF. We find all shared factors, take the lowest power of each, and then we divide the expression inside the parentheses by the GCF and simplify. You won't need to write out as many steps as I did in these videos, but I wanted to give you everything that you needed. Now, just remember, we always start with our GCF. Always, 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 always. So you have to be comfortable with this skill. And this is our leftmost, I guess this is the seed of our factoring tree. And we're going to spend the rest of our videos filling in this tree. And then once it's done, we're going to talk about the right way to choose between the different methods. Our next lesson is the difference of two squares, and I'll see you then.